10a looks at Pythagoras' theorem. So Pythagoras' theorem, you should remember, is a squared plus b squared equals c squared, where c is your hypotenuse, so the longest side of a right angle triangle, this one here. A and b, it doesn't matter. So example 1, use Pythagoras' theorem to calculate the length of the hypotenuse. So we want the hypotenuse, and this question also states 2 decimal places. So label our sides. It doesn't really matter if I use A for 4 or A for 10. I've chosen 4 and then 10 for B. Write out my formula and then substitute in. So I know that this is equal to 4 squared plus 10 squared. And then take the square root of both sides, which would remove this to C. And because I want 2 decimal places, this is a calculation I can do in the calculator with the decimals, so that gives me 10.77 as my result. This has units, so you do need to use that centimeters. Example 2 is to find an unknown side when it's not the hypotenuse. So calculate the length of the unknown side and to 1 decimal place in this case. I'm going to label the sides of my triangles, so A, B, C, where C is the hypotenuse, and then substitute it back into this Pythagoras' theorem. Now I've written Pythagoras' theorem as b squared is equal to c squared minus a squared. That's just a rearrangement of your normal formula. This gives me 11 squared minus 4.7 squared. Take the square root of both sides, and then this is what I put into my calculator. And when I do that, I'll get my solution to 1 decimal place, so 9.9. And again, this is millimeters, so you need the units. The third example is a worded question. So it's a practical problem. You need to basically break this down and draw a diagram. So a helicopter hovers at a height of 150 meters above the ground, and horizontal distance is 220 from the landing pad. We want to know the direct distance from the helicopter to the landing pad, correct to 2 decimal places. So draw a right angle triangle. Basically, you're dealing with Pythagoras, there's always a right angle triangle. The horizontal, this line here, this is your ground, which would mean that directly above the ground is your helicopter. So this is hovering at a height of 150 meters. So your helicopter, you've got your landing pad and your ground. Putting in the values that we know, so we know 150 meters, we know 220 meters is the horizontal, and we're trying to find that direct distance, which is the xm. I've put the m there, that's my meters, that's my units I'll need to look at later. So again, solve it like normal. So write out your formula, x squared is equal to a squared plus b squared. I'm actually just straight substituting in, so if you can, you don't actually have to write that formula, you can just straight substitute. Take the square root of both sides, and then that's what I'm going to put into my calculator. That is a solution to 2 decimal places, so I get 266.17, and that's meters, 277, meters. Now I haven't red boxed that because it's a worded question. So worded question needs a worded answer. The direct distance is 266.27 meters. That is what I am red boxing.